Hello everyone, this is Rabah Delfouf. I am a doctor student from Farhat Abbas University CT. First of all, thanks to the organizing committee of First National Conference on Applied Science and Advanced Materials for giving me a chance to present my paper here. My paper title is Complex Permittivity Measurement for Ternary Composite Materials from DC to 4 GHz. Now I'm going to present my paper outlines. First, introduction. Second, experimental procedures, which contain 3 axes: sample preparation, machining of samples, and characterization bench. Third, results and discussions. And we end by conclusions. Now, introduction. As the basis of all electronic functions, composite materials allow numerous applications thanks to their mechanical, dielectric, or even magnetic properties. Dielectric materials continue to play a very important role in microwave communication systems. The composite materials that we used in this study are based on epoxy resin, which will be loaded with calcium titanate and ferrite in order to determine their permittivities and conductivities for microwave electronics application, miniaturization of circuit component cavities, antenna, and substrate. Now we move to the experimental procedures. First, we talk about samples preparation. For the realization of ternary composite, we used calcium titanate and ferrite, all in powder, bound by an epoxy resin in liquid form. In this context, we have prepared several samples with different volume fractions. It should be noted that the proportion of the epoxy resin is fixed at 70% in all composites. Consequently, the proportion of the other inclusions, calcium titanate and ferrite, vary between 0 and 30%. Now, machining of samples. For characterization on TDR bench, tubular samples are needed. This shape is obtained by making an extraction with a hollow cylindrical drill of adequate dimension 7 mm in diameter from the parallelepiped samples. A hole of 3 mm in diameter is then drilled. Characterization bench. The characterization technique adopted in our study is time domain reflectometry, TDR. It is based on the study of the reflection generated by the interaction of an electromagnetic wave with the sample to be characterized, which is placed in a coaxial line. Now, results and discussions. In this section, we first talk about the determination of the composite's real and imaginary part of permittivity. In the figure of real permittivity part variation as a function of frequency, we notice that the increase of the real part as the volume fraction of calcium titanate increases. For the imaginary part of permittivity figure, we notice that amplitude spectra are almost constant for low frequencies. Secondly, we talk about the determination of the composite conductivity. The curves resulting from the conductivity measurement follow a quasi-linear trend for most composites. Finally, we conclude that Ternary composites allow us to analyze and clarify the effect of the nature of ferrite on the dielectric properties of calcium titanate. Additives like ferrite aim to reduce dielectric losses and at the same time keep the real high permittivity of the composite materials before the resonant frequency. At the end, I want to thank everyone for listening me and enjoy my presentation.